Example 2. Again, take out a piece of scrap paper, draw the line, and so when we get to this point where we have a single fraction equals a single fraction, we've changed things to sine and cos, and we're still not done. In our list of strategies, I put a red star beside 3 strategies. These are the strategies you need to think of when you get stuck. Okay? One of them was factoring. Unfortunately, in this one, there was nothing that you could factor. So the strategy of factoring, which we've seen already, also doesn't work. The other 2, which is multiply by 1 or build the other side, are really the same thing. The reason I renamed it build the other side is because, do you remember what a conjugate is in math? Something you learned in grade 11. Do you know what the conjugate of a plus b is? The conjugate is a minus b. In a difference of squares, you have 2 conjugates. This word in English, in math, is so foreign that you easily forget it as soon as you learn it. So your math teacher probably would have mentioned conjugates in grade 11, and you would have went, ooh, that's a funny word, and then proceeded to forget it quite quickly. And so because you forget that as a word, if I say, this is a good strategy, multiply by the conjugate, and you're like, multiply by the what? You're not going to remember that strategy because the word isn't easy to remember. Build the other side, though, is the same idea. So I'm going to show you, what does the build the other side strategy look like? Well, if you've got a single fraction on both sides, one of the things you can do is make them similar by trying to build the sides up so that they have, for example, a common denominator. You can do a common denominator, or you can do a common numerator. So what's missing on this side? If I wanted a common denominator on both sides, this side's missing 1 plus cos theta. And this side is missing sine theta. If I did that, at least, and I'm not even going to multiply out my denominator, can you see that at least my denominators on both sides would be the same? In a sense, I'm building both sides to look the same. What happens in my numerator on the right-hand side, since that one is easier? What's sine times sine? Sine squared. On the left-hand side, here we have a conjugate. What's 1 plus cos theta times 1 minus cos theta? That makes a difference of squares. When I multiply it out, I will get 1 minus cos squared. So we did multiply by the conjugate in one place, but it's much easier to say, I'm stuck. Why don't I make my denominators the same and build the other side so that they match each other? If they match each other, maybe there's something I can do next. So now my denominators are the same, but my numerators are different. Can you see something you can do on one side with your numerator? 1 minus cos squared is sine squared. And so in this case, the build the other side works really, really well. When do we use build the other side strategy? When we've got a single fraction on both sides and they're not equal yet. There's nothing to factor. then getting a common denominator may help us. Sometimes, if we use build the other side strategy too soon, we can make both sides really big and more complicated. So it's a strategy you want to use when you get stuck and both sides are not equal, as is this case. The other place that can be a hint to build the other side. Okay? If you look across, and you might have heard with fractions, when you have an equation, you can cross multiply. Maybe you've heard that in mathematics before. When one fraction is equal to another fraction, you can multiply across as a shortcut for doing a bunch of fraction rules at once. Okay? In a proof, you're never allowed to cross this line. So if I would multiply this way and this way, I've already disregarded the proof and I'll get 0 marks for my work. But if you look at the proof and you see if I cross multiply, do you see that I'll get 1 minus cos squared equals sine squared? Which is one of our identities. If you recognize one of your identities when you cross multiply, then the build the other side strategy or multiply by the conjugate will be the shortest way to prove it. On your factoring sheet, look at number 29. On number 29 on your factoring sheet, it has secant and tan. If you cross multiply, you get your secant squared minus 1 equals tangent squared. And so the build the other side one for number 29 will be the shortest way to do that, instead of changing to sine and cos right away. Part B. Okay. For part B, I'll let you start it again. Okay, some things to discuss with this one. First of all, I see cos on this side, cosecant squared on this side. Okay? Cosecant squared is related to cotangent squared, but since I don't have cotangent on the right-hand side, in this case, it makes more sense to change everything to sine and cos, strategy number 1, and get a single fraction on both sides. The first issue that has come up, and I walked around, and thankfully some of you made this mistake to help demonstrate this. When I change cosecant squared to sine squared, we have one of two options. Is this 2 over sine squared or sine squared, or 1 over 2 sine squared? So I saw some people write 2 over sine squared. I saw some people write 1 over 2 sine squared. And I saw some people write the step that you could do before this. Cosecant squared is 1 over sine squared. So the step before this that some of you wrote was this. That step is correct. But the question is, what happens with that 2? It's 2 cosecant squared, which is 2 times 1 over sine squared. Should that 2 stay on the top, or should that 2 move down to the bottom? Well, we have to think about how do we multiply fractions. 2 is the same as 2 over 1. So if I multiply this out, that won't happen. But you get tempted when you do the reciprocal to have that number out in front come down as well. This side should be 2 over sine squared. Okay? Now, for my left-hand side, I don't have a single fraction. How do I add fractions? I need a common denominator. What would my common denominator be? Well, I would need to multiply this one by 1 plus cos theta and 1 plus cos theta. And I would need to multiply this one by 1 minus cos theta, 1 minus cos theta. Check your work. Did you remember to have the thetas? If any time in a proof you forget to write a theta, that's an E3 error. It just has to happen once anywhere on your page. Even if you're like way off in the top left-hand corner, I'm going to write tan equals sine over cos and forget the thetas. They will see that on your exam and go E3 error and take it off at that moment. So everywhere, when you write sine, cos, tan, secant, cosecant, cotangent, the thetas or whatever variable you're using has to be there. Next, now I have a common denominator. My common denominator is 1 plus cos times 1 minus cos. Maybe you recognize that as a difference of squares and multiply it out right away. Then on the top, I'm going to have 1 plus cos theta plus 1 minus cos theta. Can you see that your cos thetas, like terms, will cancel out? Here's a really important one. 1 plus 1. That will become 2. And what can I change 1 minus cos squared to? To sine squared. And we're done. So we didn't need to build the other side. We didn't need to factor. We just needed our basic skills of changing to sine and cos and getting a single fraction on both sides. We did have one Pythagorean identity to use, but by now you're starting to really recognize 1 minus sine squared is cos squared, 1 minus cos squared is sine squared. When we started with that big idea, I said by the end of the course, you're going to feel like that is like common sense. Everybody in the world should know that sine squared plus cos squared equals 1. It's just something that you know, and you don't feel like you remember learning it anymore. Like, do you remember learning a squared plus b squared equals c squared the first time? Yeah? Or do you just think that everybody your age knows that? Do you feel like everybody your age should know that? Maybe. Okay, practice for this one. Question 12a.